Hello, my name is Aaron from Valley Christian High School, and my second milestone is where I uploaded a custom model of a machine learning algorithm to detect various kinds of trash, like this water bottle. And I also coded it to scan an image 50 times to ensure that it was getting the right results for the machine learning model. And I also coded an ultrasonic sensor so that it would scan only when it's within a certain distance. And also I encoded servos so that when it detected different kind of trash, one of them would open if it was trash and the other one would open if it was recycling. So the way the way that this works is that I think it should be both red by now. This detects the distance, and this detects whether it's within range or not. And then this detects like what kind of trash it is and with how much certainty, where 0 is no certainty and 1 is complete certainty, which usually almost never happens because it's being scanned over a certain amount of time. So for example, if I take this water bottle and I haven't attached the camera to where the ultrasonic sensor is, so I kind of have to hold it up like this so that I can get it to actually look at what the ultrasonic sensor is seeing. So if I hold it kind of like this, I think it'll move one of the servos, but it'll also freeze because while it's scanning, even though it is taking shots of individual video stuff, it doesn't actually like show you on the display because it's processing. Yeah, I think it says recyclable plastic over there, and in this case, one of the servos for the recyclable plastic would move. And later, I'm gonna translate that into like a garbage can or something. But for now, that's what this milestone I've accomplished in this milestone. So for the technical stuff, I spent a lot of time training the model and picking out images to train the model on. I had to find images with backgrounds that were varied so that because if the images are all trained on a white background, the AI will start to associate the white background with the object and not the object itself. And also, it's better to train with diverse backgrounds just in case, like, for example, this background is different from the place where I trained it in. So you have to be aware of that. And I also had to code the script that made these runs. So as I said before, once it's within range, it scans it 50 times. But if it leaves range, so like if I just hold my hand like this, like sorry, if I hold my hand in front of the ultrasonic sensor and then remove it before it scans 50 times, it will automatically not scan the item because it'll just be like a blank background which doesn't have any items in it. And an, another piece of technical progress I made was wiring the ultrasonic sensor. So all my wires on the breadboard. And since these servos and the ultrasonic sensor both run on 5 volts, the Raspberry Pi only supplies 3.3 volts. So I need an external power source, which I ran through this into the breadboard so I could power the 2 servos and the ultrasonic sensor. So this power source is regulated for, I think, 2.4. No, it's like, let me check. I think, yeah, it was 2 amps because each of these servos is rated for 1.2 amps at the very maximum. But since I'm only running one of them at each time, I chose a power source for 2 amps along with this ultrasonic sensor, which doesn't draw as much power as the servos. And I also have a voltage divider circuit in here so that the after the ultrasonic sensor sends out a pulse and receives the echo, it can translate the voltage and back into 3.3 volts for the Raspberry Pi process because these pins only run on 3.3 volts and they would fry themselves if they ran the 5 volts that this thing provided. So the way the voltage divider circuit works is that I have a ratio of resistors where the first resistor is 1k ohms and the other one is two 1k ohm resistors, so in series, which becomes 2k ohms, and this provides the necessary ratio to convert the 5 volts into 3.3 volts. And some of the challenges that I had with this milestone were the first major challenge was getting the code to actually work in the first place. I followed a lot of tutorials, installed a lot of dependencies, only to realize that the entire like system for the model that ran on Raspberry Pi was completely outdated, and they had to switch from TensorFlow Lite to Lite RT. So in the end, I in the end, I had to use some of the code from my instructors. And that's what I modified into the code that I'm running here with the ultrasonic sensor and the servos. And I also had to make a new virtual environment in Python so that I could run it without all the other stuff that I installed that could have crashed the program. And for next steps, the next step for me is definitely to make a case for all the wires and all the components so that nothing will move, and also there would be a way to attach the ultrasonic sensor and the camera together so the scanning system would actually work, and also to make uh, like small models of garbage bins for the servos to actuate on, because right now they're not actuating on anything. And yeah, that would be the next milestone for this project. And yeah, that's my second milestone.